Okay, let's start with the mensuration here. We already studied about the mensuration. According keeping the eye on the complete examination, let's do something from our problems about related to the plane figures. Let's study about the mensuration, keeping eye on the complete examination. Let's study about the plane figures. Let's study about the more examples on the plane figures. First example, a rectangle is inscribed in a square. A rectangle is inscribed in a square, creating four isosceles triangles if total area of these four triangles is 200. What is then find the length of diagonal of the rectangle. Now let's understand the problem first. We have to form a rectangle which is into a square. We have to form a rectangle which is inscribed in a square. Let's try to form this. This is be a square. Don't worry about this exact motion of square here. Now we have to inscribe a rectangle in it. Now this is a rectangle inscribed into a creating four isosceles triangle. Yes, I can see the triangle here. The triangle. This is a triangle. Yeah, it says it's isosceles triangle. Now, if the total area of this four isosceles triangle is 200, we have to find the length of the diagonal of the rectangle. This is a newly formed rectangle. Let's name this rectangle as A, B, C, and D. Now, it is given. This is our four isosceles triangle, and the area of the cumulative area of four isosceles triangle is 200, and we have to find the area of the diagonal. We have to find the length of the diagonal of the rectangle. We have to find this length. This will become, let this be x. This is isosceles triangle, therefore this would be the length of this side is, and length of this side would be same because it is a square. Let's assume this length be y. Now this would be isosceles triangle over. Total length of this square is become x plus y. Therefore this length should be x plus y. Therefore this length has to be y. Right? Understood? This is a square. All the lengths should be same. This is x. We have assumed this is x. We have assumed this is y. Therefore here it is. If it is x, this is isosceles triangle that becomes x, and therefore by default it becomes x. And now similarly it becomes all the length become x plus y. The square. Right? We got the four isosceles triangle. All are the right angle triangle. This is very important here. Isosceles as well as right angle triangle. Area of right angle triangle here is base into height. Now this is 1x into x, that is x square, plus half. Second, y into y, that is y square. Now again x into x, half x square. The fourth area, half y into y, that is half y. Now therefore I can say the area here is x square plus y. Now this is, and we get the equation x square plus y square is equal to 200. Now we have to find the diagonal of this rectangle. This is 90 degrees because it is a rectangle. Now we have to find this diagonal. Now let's calculate the length of this DC. The length of this DC would be, this is 90 degrees. DC length would be under root of y square plus y square. We have applied the Pythagoras theorem here. This is length is y, this length is y. Therefore this length has to be under root of y square plus y square, that is root 2 y. Similarly, let's calculate this length. This is AD. Now this length should be, let's apply the Pythagoras theorem. This is 90 degree x, that is under root of x square plus x square. Now this AD is equal to under root of x square plus square, that is root 2. We got the value of AD, we got the value of DC. Now again it is a right angle triangle, triangle ADC. Look again, triangle ADC. Let me clear it more. ADC. Now ADC. We know the length AD, we know the length DC. This is 90 degree, and now I can calculate the AC, which is exactly equal to the diagonal of the rectangle, that which we have to calculate. Now AC become under root of AD square plus DC square. Now under root of AD square plus under root of DC square, that is under root of 2x square plus 2y square. Right? Now under root of 2x square plus 2y square, let's take out common 2, that is x square plus y square. Now x square plus y square we have already calculated with the value of x square plus y square here is 200. Let's put this value of 200 over here. This becomes under root of 2 into 200, which is 200 into 2 becomes under root of 400, which means the value is 20. The length or diagonal of the rectangle form is 20. Now, if the question would be asked, what is the length of the square? It can be asked, what is the length of the square? The length of square is x plus y. Now we can have to calculate the value of x square, x and y. This is your homework. Calculate the value of x plus y. Now, coming to the next problem. On the problem, figure is given. Triangle ABC is right angle at the angle C. DE is perpendicular to AB. Given is angle C is 90 degree. DE is perpendicular to AB. Next thing is given. AE is 6. EB is given 7. And BC is given 5. We have to find the area of quadrilateral E, B, C and D. Mark all the points. Let's mark it. Now this is 90 degree. Now marking the things. AE is given 6, right? EB is given 7 and BC is given 5, right? Now we have to calculate the area of quadrilateral ECBD. This is C, this is D. Length AC. Let's apply the Pythagoras theorem here. AC square plus BC square should be equal to AB square by the Pythagoras theorem, which is right angle angle C. Now AC is under root of BC square. AC square minus BC square. AB square is minus BC square, right? Now which is equal to AB square is AE plus EB, that is 6 plus 7. 6 plus 7 gives the value 13. It's 13 square minus 5 square. The value here is 169 minus 25, which is equal to under root of 144, which is equal to 12. Now we got the value of AC here. Value here is 12. Let me mark it up. Now see it carefully. See the triangle AED, and now what's the triangle ABC? Triangle AED and triangle ACP. I am saying so. In triangle AEP, I can say angle E is equal to angle C. One angle is equal. This is 90 degree and this is 90 degree, right? Now angle A equal to angle A, which is common in the both the triangles. Now I can say the triangle AEB is similar to triangle ACB. I have used the word similar here. I have used the similar word. I can say this is similar by the congruency by the similarity of two angles, that is angle AA. Now angle A is here, C is equal to angle A. Angle AEB is equal to angle ACB, which is 90 degree. So we have used the congruency here. Now we can say the sides are into the common ratio. Now I can say AE upon AC is equal to ED upon CB, right? Now AE upon AC is 6 upon 12, which is equal to ED upon CB, and CB is already given, that is 5. We put the value of here, 6 upon 12 equal to ED upon 5. Now ED is equal to 2.5. Now area of quadrilateral EB, we know have get the value of ED length. Now we have to find this area of this quadrilateral. Can I calculate this quadrilateral by finding the area of triangle ABC and subtracting the triangle of this ADE? Now I can easily calculate triangle ADC because I know the ED and the angle is 90 degree and this is the base is 6, right? Now triangle ABC, which is 90 degree at this angle, I can easily calculate this area because this is 90 degree. That is half base into height. 5 into 12. Half 5 into 12. Now I can see the important thing is area of quadrilateral ABCD is equal to area of triangle ABC minus area of triangle AED. Right? Now triangle ABC area half 5 into 12 minus half area of triangle AED is half 6 into 2. Now half 5 into 12 is 30 minus area of A is half 6 into 2.5 is 7.5, and the area of the given quadrilateral EBCD becomes 22.5.